Wait a minute. How do you read that? I don't have it good enough.
All right.
Kyle's gonna be back.
You did those all?
Almost straight.
Oh, good. Yeah. And yeah, if you guys get parts of the review done and you want to check, I do have an answer key that you can end up checking, and that way you can know if you're doing things correctly. I would suggest waiting, to check them until you've tried them yourself first. So the first thing is that the A is the amplitude, and that's how high and low the graph goes. But the amplitude is only basically half of the height. I guess I would say, like, it's not from the max to the min. So the amplitude is how high or low it goes. And that's for all the graphs. Now the amplitude doesn't really impact the tangent and cotangent, but it doesn't hurt to know that that's still the amplitude there. Okay. The next one is the B, and that impacts our period. And this one depends on which type we're talking about. So sine, cosine, secant, cosecant is 2 pi over b for our period. Whereas tangent and cotangent is pi over b. C and D impacts the moving of the graph. It moves it left, right, or up or down. One of the things, though, to be careful about is that moves the starting value typically. So when I talk in a second, I'll talk about where these graphs start. And so the C and D might shift that. So just being aware of that point there. So C moves us left and right, but it does the opposite of what we expect because of the minus sign there. So if C looks positive, it actually moves negative, or moves left. If it looks negative, it actually moves right. So it's the opposite. Whereas D moves it up and down, and that's normal. So that doesn't change depending on the sign, or the sign is what it is. And I was going to kind of give just a quick, like, if there's things we need to know about each of the trig functions as well. So, like, the easy ones are sine and cosine, or easy-ish. Sine and cosine, it's where they start. So sine typically starts at 0, 0. And then ends at that 2 pi, or, like, goes that full revolution there. Whereas cosine starts up and ends up when it's done. And it's going to start up at like 0a, whatever the amplitude is, or 0, 1. Was that first hour we had like a chorus of sneezing? I think it was like different parts of the room. It's almost like we planned it. All right. Now, remember that cosecant and secant need the sine and cosine graphs first, so I probably should have drawn those. So I had these flipped, the wrong ones together, but so my cosecant graph goes with sine, but I don't just leave it as the sine graph. Remember, we have to draw in like parabolas at each of the max and minimum points. And they should touch the graph, like touch the top and the bottom, and just a little bit off there.
Is this the one with like the dotted lines on the sides?
This one has dotted lines in between. If you want, yes, they do have like kind of those dividing lines, but tangent and cotangent, those are necessary as well. So cosecant, and then secant will do. Secant goes with cosine. And so again, mentioning what Esther asked about, basically between each of these, where it goes through 0, there should be really an asymptote. We don't have to draw those are like imaginary lines, but technically if we wanted to be completely like perfect with our graphs, we would draw those in. I'm only picky about this if your parabolas are totally crazy, and let me just draw you an example of what I mean. So if you draw your sine graph, and then your cosecant goes something like this. I'm not trying to be picky, but technically it's supposed to like stop at like this point, so you want to make those skinnier. So nothing like where I'm going to like be judging how far over you can go. It's just don't make them like these super crazy wide graphs or super skinny either. Like. All right. Now tangent and cotangent probably are a little bit tougher here. So tangent is kind of squiggly uphill. And tangent starts with an asymptote. So it doesn't actually cross 0, 0 unless it's moved over. So it goes asymptote, then 0, then asymptote, then 0 is the kind of our alternating. And so it starts with an asymptote at 0. And then again, it crosses at pi over 2. So if maybe the way I should say this isn't the way I said it before. Let me explain it a different way, or the way we've been doing it, is where the asymptotes are. That might be better to put it that way. So there's asymptotes at all the whole values. So 0, pi, 2 pi, unless those get shifted. Where cotangent goes downhill, and it's just the opposite. So it starts at 0, and then there's an asymptote, then it goes 0. So this one, its asymptotes are at the halves. So do we want like an example of something? Yeah.
I have a question.
Yeah.
On my note packet, it said that the tangent asymptotes were at the halves.
Do I have that wrong? Dang it, I think I do. Thank you. Kara, you guys, I'm sorry.
Everyone makes mistakes.
All right, did you write in pen? Hopefully you didn't put on your note card. You want white out? I have white out. Thank you.
Wait, so
I'm wrong. Everything I told you is wrong. I'm a failure. Sorry. Here, white out.
wait,
Oh, you
how
just
did
gonna
you-
flip it? Okay. So technically this should all be flipped. And what I was doing, you guys, I was looking at my test, and this one was shifted. So that's why I was, yeah, sorry. So I'll fix what we have.
So are the lines right or no?
Does tangent go
Or
up?
wall.
And tangent goes uphill, cotangent goes downhill. I got that.
Okay.
Yeah, these should be
everything else
flipped.
Okay,
So, yeah.
That's
Do I? I'm not gonna try to move them, I don't think. I don't think they'll move. Is that cheating?
A little bit.
Just because you're mad at me.
Yep.
All right, sorry. Thank you, Tara. Thank goodness for Tara.
You were like writing our finals and later.
Like, why are all these kids so wrong? Like,
And then you'd be like, oh, I told him that.
yeah.
And then you would have, Tara, you should have told her because we could have just done it wrong and everyone would have done it wrong.
Perfect.
And then she would have just had to get, like, beat on that part of
Do
the
you know how
class.
to work that, Sam? Did you break it? I think you broke it. No, I don't think you did. Maybe you did.
Say on.
That's
Slam.
allowed. That's allowed.
Usually you can like fix it by making it go back in.
Take a lap.
That's allowed. I never should have kept going
There.
again, but like I did it.
So you just drive it, yeah.
Drive my fast enough? That's better. Let's not been drive.
He gave the last.
All right, should I do a tangent example now that I scared you? Okay, all right. All right, I'm not scared.
I've never been scared.
I'm absolutely terrified.
Oh, I'm the bomb.
Can I get video?
If there's one file, I'm the bomb. It's this one. Yes.
Wait, I actually want to do something.
What are you doing?
Holy shit.
What
You got the combos.
That's
Yeah, I
cheating.
didn't tell any of them, but that's what they were.
I don't have combos.
Wait,
No, she did like a bunch of searching out.
Yeah, I have like little pictures. You can either have it XY axis or you can put a xylophone.
Oh no, it's.
Wait, what's the xylophone?
Please.
What's this for?
Oh, yeah.
Very useful, not gonna lie.
Because I search for XY because that's how I find my graph,
Oh, yeah.
like the pictures
So
here.
let's search for
And
something.
xylophone was, or glockenspiel.
What is that?
It's like
It's a band instrument, right? They do that.
I think you should leave those right there.
They're not in the way at all. Oh gosh.
Uh-oh.
Okay.
Actually, kick your arm.
It's kind of embarrassing.
No. No. Oh, you just copied it.
There's a
Come on,
delete
accidentally
button.
paste it.
What?
There's a delete button.
Delete.
I have. It's right below paste.
Then why don't I believe you?
Okay.
What's
Alright.
the difference between deleting and spell?
Why is it?
You need this gun.
It's a copy.
Oh.
Shut up.
It's like copying while like getting rid of it instead of just like trying to hit copy and then
No, it's because you haven't done a
it's just
bang.
like cuts it and it
Or you know.
You did not know that?
No.
What's it video me?
Did we know Jolie was gonna be gone today?
Who was on first class?
She was here early. Wait,
Oh, she
she
was.
wasn't.
You skipped.
No.
Sounds like Jolie.
Says you.
Send the school.
Yeah,
Yeah,
Hi.
Skipping morning workout.
Oh my gosh.
Back to the morning.
John, bad boy.
That's allowed.
You took my pencil sharpener and pulled it apart. You took a weapon. There was a razor blade in that. He has a weapon. Officer Ross.
Do you see it back there? Okay. All right. So let's do this one together here. So tangent of x over 2 plus 3. You can just kind of sketch it freehand if you want.
You just look at it.
Or you can just look, you don't have to sketch it. Okay, so what's happening in this case?
Something. Oh, it's going to.
What's that? Math. Of what? Okay, I thought you said 4, so I was a little worried. Okay,
I said four.
He said four.
okay, so
We all saw it.
up 3, so rather than crossing at 0, it's gonna shift up 3. Now typically, thanks to Tara, we realized that there should be asymptotes at the zeros and the whole numbers. So typically there's asymptotes at 0, pi, 2 pi. However, this is x over 2. So what does that do?
Isn't it the other way?
Wait, isn't that?
Do I have them wrong again?
Oh my word.
Yeah, you do.
I do.
Oh my god.
We forgive you. We forgive you.
I don't.
Early practice.
Let's just exempt the yeah, let's just like exempt this part of the file at least.
Exactly.
It's
You're
just not
even confusing
it's not
yourself.
you if you keep getting tripped up.
I
What makes you
know.
think we won't?
So Miss Dunny, if I even get it right on the test, you're gonna mark it wrong.
There's
So
no, I don't
which
think
way.
That was clean. That was
she's still kidding.
I'm still confused. Look, quiet. She's still confused. Thanks.
She does so
She's
much.
still stupid. All right.
I didn't say anything.
What? All right.
That's wrong.
Yeah.
What? Is it? I don't trust anything. However, you guys, we changed the period in this case. This x over 2, that b value is 1/2. So we have to change our period in this case. So it's 2 pi over 1/2. Not 2 pi, 1 pi. Yikes, I caught myself that time.
That was good.
Thanks.
Hooray.
Okay,
Hey yo. Hey.
so
Jump
So,
on that button.
guys, dividing by a half is the same thing as multiplying by 2. So the period actually becomes 2 pi. So this graph actually becomes wider.
Yeah.
Now, that also changes our asymptotes though now, the ones that we don't know where they are anyway. So we have to multiply them by 2 just like we did with the period. So now there's going to be asymptotes at pi, because 2 pi over 2. Then this will be 3 pi over 2, so 3 pi. So if I'm doing my graph here, I have pi over 2, pi, this will be 2 pi, 3 pi. So I have an asymptote here and here. Then there'd also be one at negative pi. Now my tangent graph should go uphill, and typically it would go through 0, but it doesn't go through 0, it went up 3. So it should go through 3. 1, 2, 3.
I thought you said they were supposed to be wider.
They are wider.
Well, it's depending on how you mark the graph.
Normally they'd be like,
What do you think?
What do you cleansing?
you might even do it like pi over. It just depends on your like, yeah, how wide you make your graphs. But technically, this is wider than a typical one.
Hey, sharing is
What was that?
All right, how are we doing?
Sharing is caring.
Real sharing. All right, do we want an example of any of the other ones?
Yes. All of them.
Yes.
The CSC?
Yeah. Right, Tees.
Hey, whoa.
Whoa!
Luke.
What would you do? What would you do?
Luke, what was
Good
that?
job. Good
You
job.
started it. I did not.
You got another xylophone up here?
Yeah.
Yeah.
Luke,
I'd rather have a guitar this time.
Luke
I have to
is
search for
xylophone.
something different for guitar.
Luke, how about you teach us?
Guitar.
I could.
Okay, let's see it.
Okay.
You can draw a guitar.
Luke said he would like to teach the class.
No.
I never said that.
What are we on right now?
He said he could.
I just said I could.
I think Catherine wants to teach it.
class.
Yes.
Go ahead.
Yes.
That'd be awesome.
I just.
One. Oh.
Okay.
Let's go to the gold channel.
So the amplitude is 3.
Go to
Oh,
the right. Half pi.
Yeah, Luke.
Pi half.
Okay.
No.
And it's a sine graph.
It's like in the middle of the day.
But we have to take that sine graph and shift it to the right, pi over 2. And we have to do an amplitude of 3. So my graph here, we're not used to these graphs. Typically we have a little sine graph, but, or like a different, like the graphs are usually shorter. But guys, so 2 pi would be here. So typically my graph would start at 0, go up to 3, back down to 0. So like it would be like this, but I'm going to shift it over pi over 2. So is it okay if I shift that right away?
Yes.
So I'm going to go here, and then I'm up to 3, down to 0, down to 3, back to here.
Kind of like when you do the dotted lines.
Yeah, this looks
It
pretty
makes
good.
me so happy.
Satisfied.
It annoys me. Literally only apple.
What's up?
I actually asked myself.
We're supposed to go to the right, pi over 2.
Whoa! I need to the right! Let's go!
Good job, Sam. What happened?
We went to the left. I need to like go home or something. Like,
You want me to take you on this time? I can do that.
Hey,
Hey, yo. You
I
left.
can go home.
can't get all of you guys with me.
Well, I'm gonna be at 1 and I'm not coming back, so
You ruined it.
Oh my god.
Can you take me home?
I wish.
It's so cold.
Wait, we're going for a walk.
No, we're not going for a walk.
We're going home.
Let's go home.
I said, don't.
Let's go.
You going to?
Wait, John, don't you have a pickup truck?
Take all of us.
Yeah. You don't have a
You're
pickup
gonna take like 8 people in the back.
I have the minivan, the white minivan that steals kids with candy.
Wait,
Yes.
At least it doesn't say free
Next
Wi-Fi.
time you're driving the van, I would get in the van.
I would jump in the van and be like, where's my share?
a van like that
If-
parked
if-
next to me at the gym.
Don't always say,
It's
give
not-
me the
We
candy.
should like 1 year.
I'm never getting the
Put free
van.